Rocky, shh. What we do want to focus on today would just be one, name or maybe identify what right angle triangles are. Two would be to name the parts of a right angle triangle. We've got there the warm-up question. Those are diagonal lines. How long are those red lines? From one dot to the other, talking about horizontally and vertically, it's 1 unit, okay? Diagonals might be a bit of a different story. So what do you think? Who would be able to give us a good estimate? And I won't be giving you the answer now, but maybe what you can write down in your books would be just your answers for these ones. So you could probably name those red lines, red line 1, 2, 3, 4. I can't write on it. Hang on. I think I can. Wait a second. I can do that. So you could probably say, or write down in your books. So this is line 1. This is line 2. This is line 3. It's cold outside, but I did promise a lesson outside. So here we are, even if my hands are cold, and you can see that from my writing because it's a bit crooked. So again, I'm not giving you the answer now, but hopefully as we progress in this unit, you'll be able to let me know what the answer is. So Umang said 3 units for line 1. That was his estimate. How about you? What would be your estimate for line 1? And then write down your estimate for line 2, and then line 3, and then line 4. I'll give you 1 minute. Okay, write it down. All right, let me know next time. Maybe highlighting today and the next few lessons on our right angled triangles, because today we will be just focusing on a certain theorem we call Pythagoras Theorem. In a right angled triangle, there's a relationship between the sides, the lengths of the sides of a triangle. What is the relationship? Well, firstly, he named the sides of these triangles. This here, that is our hypotenuse. 2 important things about the hypotenuse. One is that it's always the longest side, and it's always the one opposite the right angle. Okay, when I say opposite, it's in front of you, right? So when you have this, let me use a different color. So this is our right angle there. Can you see that color? And the opposite side would be C, all right? That's your longest side. This is your right angle. The one opposite, the side that's opposite that angle is your hypotenuse, because those are just the 2 things that we want to establish today, all right? And the ones that you will be using for you to be able to do your work for today. Are there any questions for now? Other than, where is Rocky? Stay safe. Bye. So today we'll be looking at how we will be able to find the hypotenuse. Yesterday we introduced right angled triangles, and we said something about the hypotenuse. Who can remember what were those 2 things that we said about the hypotenuse in a right angled triangle? Right angled triangles would be triangles that would have right angle, right? And we named these 2 sides, A and B, as our legs. Yes. Other terms for that would be just the shorter sides. And they are called the shorter sides because we know that the hypotenuse, which is normally we call C. So it's always the longest side. That's why the legs were called the shorter sides, right? It's also the side that's opposite the right angle. This side faces your right angle, or you can say the right angle faces that longest side. Yeah, so they are opposite each other. Could there be any two right angles in a triangle? Someone said something very important about the triangles yesterday, that the angle sum of a right angle triangle is 180. So going back to my original question, could there be any two right angles in a triangle? Anyone? No, why not? You can't have two right angles because it would equal to 180 in total. And it becomes flat, right? Or there wouldn't be any angle measure that would be left for the third one. And we said that triangles need to have three angles, exactly three angles, no more, no less, right? Has to be three angles, right? And therefore we would always have as well just one hypotenuse, all right? It's always the longest side. It's always the one that's opposite your right angle. We've got a warm-up question here. Which of these square numbers also happens to be the sum of the two smaller square numbers? Who understood that question? If you did not get that question, you are not alone. And that person actually even cost him $15,000, right? And if you want to know about that story, you might want to click on that link, all right, and watch that video. So what are square numbers? Square numbers. What are square numbers?
That can be times by 4.
Can be times by 4.
Or divided.
So when I have, for example, 4 can be times by 4, or 4 can be divided by 4. 4, would that be a square number?
Yes.
Yes. How about 16? I can times 16.
Yes.
I can divide 16 by 4.
Yeah.
We'll have about 25. Can I divide 25 by 4? No, but 25 is a square number, as well as 1 is a square number. 36 is also a square number. Well, 36 can be divided by 4. What else? 25, 6. 49 is also a square number. But those numbers, 25, 1, and 49, can't be divided by 4. So who can give me a refined definition of a square number? Anybody? Why do we call them square numbers? Everyone's quiet, thinking. I'll show you why they are squared numbers, and maybe you can give me later what a redefinition of your square numbers. So I can draw a 4 looking like this. That's 1, right? We forgot something. We can have 9 there. Oh, not there. Over here. And I would say that I can draw it like that. Yeah, I can draw 16 like this. So can someone tell me why they are called square numbers? Doesn't look like a square, does it?
Wait, Miss, is it because like they have the equal sides?
They have their equal sides, and if they have equal sides, what do we call that shape?
A square.
Square, precisely a square, right? That one is a square with 2 dots. This one is a square with how many dots?
4.
4 dots.
16.
Yeah. That's 1. This is 3, right? And that's why when we have 4, we would have that's 2 squared. What's 16?
4 squared,
4 squared. How about 25?
5 squared,
5 squared. That's why they are called your square numbers, right? So they are numbers that aren't, well, not all of them can be divided by 4, but they are numbers that would be a result from squaring a number. So when you square 1, you get 1. When you square 6, you get 36, and therefore you say 36 is a square number. When you square 7, you get 49, and therefore you say 49 is a square number, right? The same thing with 3. When you square that, you get 9, and therefore you say 9 is a square number. Now, which of these square numbers also happens to be the sum of the 2 smaller square numbers? When you say sum, what's the operation? When you say sum, what's the
addition,
addition, right? So when you add 2 square numbers, you end up with one of these. Which one is it? And I don't have $15,000 to give to anyone who finds out the answer, okay? I'm so sorry. 16 and 9, yes, are square numbers. And when you add 16 and 9, what do you get? 25, yes, and 25 is a square number. So which one is the answer there? It would be 20, the second option, so 25, okay? So if you haven't watched that video yet, you can watch that later. Today we'll be looking at finding the hypotenuse, and maybe you'd find out the reason why we had that warm-up activity about square numbers, okay? Because we will be squaring numbers. We established yesterday that the Pythagoras Theorem, Mr. Pythagoras, defined a theorem. He discovered this, and during his time, a lot of people wanted to know what he discovered. Okay, it was something that's like a top secret. Okay, so Mr. Pythagoras said that in a right angle triangle, he actually discovered it from a square. He was measuring a square, and he can measure all the sides except for the diagonal, right? And what he discovered is that in any right angle triangle, the longest side, which is the hypotenuse, the square of that is always equal to the sum of the squares of the other 2 sides, or the shorter sides. Okay, so that's what he discovered. C squared equals A squared plus B squared. Okay, so looking at our lesson today, it says finding the hypotenuse, right? We want to find out the value, the unknown x, all right? If you're given the 2 sides and you know that it is a right angle triangle, right? If you're given the values or the length of the 2 legs or the shorter sides, then you would be able to find out what the length of the diagonal or the hypotenuse, okay? How? You would use that formula, C squared equals A squared plus B squared, okay? And we know that C would always be your longest side, so, and it's the one that's opposite to your right angle, and therefore you would know that X would be our C. You can have 4 as A, you can have 7 as B. Your A and B can swap, right? But your C would always have to be the longest side. It would always have to be the one that's opposite your right angle. You say X squared equals 4 squared plus 7 squared, okay? When I say squared, when I say 4 squared, does that mean 4 times 2? Or does that mean something else? Do you know where to find the squared button on the calculator? The one that says times 2, is it times 2? X to the power of 2, hang on. Let me turn that on. Can you see it? Yeah. So you see how you've got the x squared? Yeah. So when I put 4 squared, right, it shows that one. All right. If you've got this calculator, it should be just the same. You've got 4 squared. Okay. This is my very old calculator. I think I've had this for 20 years already. If you have this calculator, I don't think you have this. This is 20 years old. All right, so you've got 4 squared. So that sometimes it looks like that. And if you press equals, you'll get 16 as well. Okay, yeah, at 4 squared plus 7 squared. And what do you get? You get 65. My camera is slow. Yes. All right, let me go back to that. And we now know the answer. So 16 and 49, was it 65? X squared, oh no. Now you want to just have x. How do you find just the x? You get the square root. So when you have the square root, that's the square root sign. You press 65, square root, and then press 65. Where is that on the calculator? It's this one, yeah. So you press square root, and if you had your previous answer, you can always use that answer button, all right? And you press equals, and Seth was right. He said it was 8 point something, right? So when you press that, you get equals 8.06, and you say 2 decimal places. Do you remember our warm-up yesterday? This was our warm-up. So what I asked you yesterday to do was to estimate for me what would be the length of those red lines. Now, we now know our Pythagoras theorem. These are all diagonals. Are we able to come up with right angle triangles? Because we know that we can't just draw any triangle, right? They have to be right angle triangles. How can I write? Which one do I press? This one? Yes. Ooh, all right. So we can't just simply say, well, I can draw a triangle here and that's a triangle. Yeah. We don't know if that's right angle triangle. But what we want to do would be to come up with a vertical and also a horizontal that would connect them, right? And form right angled triangles. You can draw them below the line, or you can also draw them above the line. Okay, and it doesn't matter as long as you draw up some horizontal and some vertical lines, right? So the same thing with this one here. It doesn't want to move, so I'll just move my iPad here. Yeah, so and then write down your symbol, that square symbol for your right angle triangles. Yeah, the same thing with that one. Ooh. Same thing with that one. There. If you want to use rulers, fine. If you don't want to use rulers, that's fine. If you want to have your lines similar to mine, which are a bit squiggly at times, doesn't matter. Okay, so now you've got your triangles here. How would you find your red lines, or the length of the red lines? What you want to do is to count how many lengths, or what would be the length of each of your vertical and also your horizontal line, right? And therefore you've got there 2 units, this is 2 units, this is 3 units, this is 2 units. Yeah, and you can do for line 3 and line 4 later. But I'll show you how to do the lines 1 and 2, right? So we want to find out, again, that would be our longest side and the one opposite that right angle in that triangle. And therefore I know that that's the hypotenuse, right? And I would be able to use the theorem, the formula, c squared equals a squared plus b squared. And again, it doesn't matter whether this is a or that's b or the other way around. Okay, so then I would just replace the value of A there, which is 2, and the value of B there, which is as well 2. And what's 2 squared? That's 4 plus 4, that is 8. Am I done here? No, I don't want C squared. What do I want? I want C. Thank you. And how do I get C? I need to get the square root of both sides. So if I get the square root of C squared, that just cancels out. I get the square root of 8. What is that equal to? 2.83. So the critical number, the next digit is 8. So you add 1 when it's 5 or more. Yeah. So you get 2.83 okay, units. Okay, let's do another one here. Our last example for today. C squared equals, you can say this is A and that's B, right? We know this is C, and we replace them. We say 3 squared plus 2 squared, that's 9 plus 4, and that's 13. And C, therefore, is the square root of 13. 3 point, again, that's 61. Okay, I will be staying online. Okay, all right, stay safe, stay well, and stay awesome. See ya. Bye.
Bye, Miss.
Bye, Miss.
See you later.
Bye, Miss.
Come on, Rocky, let's go.